Welcome everyone to the along to the afternoon sessions for GSE Virtual. This is the app dev stream. I'm standing in for Stuart, so I very nearly said DB2 stream, so ignore me if I mention DB2. That's what I'm normally presenting. Today I'm glad to introduce Fabio Alessandro Licati, shortened to FAIL, so that makes it easier for everyone to refer to our presenter today. And he's going to present a session on modernizing the mainframe with modernizing mainframe workload with Red Hat OpenShift Platform. So looking forward to that. I was going to come anyway, so I'm proud to be presenting. Over to you. Over to you then, Fail.
Thank you. So I think it makes sense to start from the very beginning, which is why containers? Because everything we are going to talk about today is container-based. So what is a container and what actually is the advantage of it? So first of all, let's be clear, even though those are the containers showed in this picture, those are not the kind of containers that we are going to refer to, because we are going to refer to software containers more than hardware containers. Though there are a lot of characteristics of hardware containers that are also the same for software containers. So the first one, and probably the most typical one, is the fact that containers can be on very different platforms. So physical containers can be on trucks, can be on boats, or trains or whatever. And the reason why containers work and are effective and therefore used in a lot of different situations is that they create standard formats so that they make complex material to be easier to be managed. So for instance, a crane, as long as can lift a container, can lift any container, or up to a certain size, but still any container independently of the content. So if we go to containers and why they matter, which advantages do they have? So the first one is less overhead. This is compared to VMs, for instance. If you have a VM, also you have the whole operating system first and then your application. If you want to package things in a more dense way, also you don't want to have too many operating systems around. So a container can help you on this. Another big advantage that they have is that they arrive with increased portability, because a container, as for physical containers, they can be easily ported from one machine to the other without caring too much about the environment. There are some asterisks here and there, but still they are fairly portable. Another big advantage is that more consistent operations, in the same way of the crane for a physical container, it also applies for software containers. And the reason is that, for instance, you can have a tool that knows how to download a container, and it will be able to download any container. Or a tool that allows you to do certain operation like proxying or other kind of things on a container, and it will work for any container. There is also an aspect about efficiency. This is mostly connected to the VM alternative, but still they can be very efficient. And also they allow better application development. Now, you have to consider the fact that containers start in x86 world. They now are in any kind of operating system and any kind of architecture, but still the idea is that once you have developed certain practice to operate on certain container, it will be easier to bring them on other containers. So this means that there is a bigger community developing best practices around containers rather than that specific application. So what are the use cases of containers? The first one is probably the one that had the biggest luck in a certain moment and period in time is the lift and shift, which is basically you have an application running, you just pick it, lift it, and shift it to a container. That would means that it's still exactly the same application, it just runs in a container, so it gets some advantages uh, since it's running from a containers, because you are at this point able to use all the tools that are able to work with containers. Another one, which is slightly more complex, is the refactor an existing application for containers. So effectively, this means that you are not just lifting and shifting it, the application to the container, but you are restructuring the application to better fit the container features, and therefore getting the most advantages out of containers. And then obviously you can develop new applications that are immediately container native. So in this case, you will immediately develop all the patterns that are more typical of a containerized application. What they allow you is to provide a better support for microservices architecture. And here, microservices is a loose term. A microservice can be 50 lines of code for someone and 1 million lines of code for someone else. So it's not really a thing about being small, it's a thing about being of the right size based on the application that you're running or the service that you're running. There is an aspect that is very connected to the container itself, which is CI/CD, continuous integration and continuous deployment. And the idea here is that you want to have continuous tests to your images, as well as continued deployment of your images in production. Now, this, as the previous one, is has some asterisk. Obviously, continuous does not mean every commit for everyone. For some companies, surely it does mean that. For other companies, continuous can mean like daily or weekly kind of thing, but still way more frequent than with other paradigms. There is a big aspect about containers and that right-sized container that you can then use that container again in multiple other services or applications, which means that you can reuse all that part of code as if like it's a black box. Let's say that we have a container that does queuing things in Kafka. So an application that will need to do that queuing things in Kafka can directly use that container. Now, that can be an example of a container, but also you can have like a key value database. You don't really care which key value database is, maybe you just need a key value database. So every application that you have that needs that key value database, you can use the same container for every one of those. Now, we have spoken multiple times about tooling. So tooling is a critical point of containers, one of the biggest advantages. And one of the biggest tools that raise into this container space is Kubernetes. Probably majority of you, if not all of you, have already heard about Kubernetes because it's kind of a well-known name. But if we go a little bit deeper, what is Kubernetes? Kubernetes is an orchestrator, so it will orchestrate your containers. But it does a bunch of additional things. So one of the things it does is that it allows to do service discovery and load balancing. So effectively, it's not like having 50 containers running on your systems. It's more like having multiple similar copies of the same containers. And then Kubernetes will load balance the load or the workloads, the request to those containers so that they are load balanced. But also, if one of those expires, disappears, it does not receive any more traffic. So effectively, all the traffic gets forwarded to the valid copies, while if a new one gets blown up, it will start to receive traffic. So it's an orchestration about all of this. Another feature that Kubernetes has is that it manages storage. Not directly, because you will still need a storage provider, which could be a NAS, a SAN, or any other kind of storage provider. But still, the idea is that when a new container that will need to be attached to a certain storage needs to be spun up, Kubernetes will ensure that that container is actually attached to that storage. And when a container dies, obviously all the connections will disappear. A feature that container Kubernetes has is the concept of applications, versions, and so on, and therefore it's able to upgrade to new versions your applications. Obviously, you have to tell him to do so, but in doing so, it does have different strategies. So, for instance, it can do blue-green deployment or canary deployment, of rolling deployments and so on. So when you decide to do the upgrade, you can choose the strategy, the speed, and everything else, and then it will perform it to you. So this allows you to ensure that no traffic gets lost in between versions. And obviously, in the same way that you can do rollouts, you can also do rollbacks. In one aspect of Kubernetes is that it does POC, so it does reuse, let's say, some binaries in between different applications. So you do have an advantage of performances, basically, resources. Another advantage is self-healing. So what you do is you say to Kubernetes, I want 5 copies of this. And if for any reason the number of copies goes to 4, for instance, so a container dies, for instance, Kubernetes will restart that container somewhere. So that it always tries to have in the real world that desired state that you described it. Another advantage that Kubernetes has is that it allows you to, well, it will manage for you secrets and configuration, and which means that if you say that a certain secret will need to be available for a certain amount of containers, then those containers will have that secret and all the others will not. Same thing with configuration management. So effectively, if you say to Kubernetes, this specific configuration will need to be available for those containers, that will happen. So just a couple of names that are important in Kubernetes. One is a container. And just to be very clear, a container, if we are talking about Linux containers, is effectively just a process. So we don't really have performance losses due to the fact that that's a container, because it's standard Linux process. It will have some C groups limitations. C groups is a way of limiting processes within Linux. And the way containers are done in Linux is basically that process gets limited on the amount of resources or the capabilities that it will have. But for every performance aspect, that's going to be a standard process on the machine. The container image is a compressed file that will contain all the files that are needed for that containers, which usually means some libraries, some software, maybe some configurations, or any other kind of files that software will need to be run. A pod is really what Kubernetes manages, and a pod is just a group of containers. Those are usually different kind of containers, but they are always co-located. So let's say, for instance, that you have an application that has 2 containers, and they talk a lot with each other. So you always want to have these couple of containers co-located on every machine where they will be available, and therefore you will put those couple of containers in a pod. Consider though that in the majority of cases, pods tend to be 1 container big, or in the best situation, every pod would be only one container big. So effectively, it's only going to spawn one container per pod. Now, that's not always feasible due to some constraint that you might have, your application might have, but that would be the preferred state. There is then the concept of service. We have spoken about load balancing and discoverability. That's leveraging Kubernetes services, which are basically a declaration of what a service looks like and which pods will be able to serve that service. The concept of persistent volume is linked to the storage management that we've spoken before. Those persistent volumes are in effect disks, virtual disks, that get used by containers, or better by a pod. And Kubernetes will ensure that they are always available for the pod to be used. There is then the concept of config maps. That's the configuration part of Kubernetes managing your configurations. So the usual way of how Kubernetes will expose those configuration to your pods is either via file or environment variable. There are other options, but those are by far the most used ones. And secrets are effectively just configuration maps with the twist, because also they can be encrypted. So how does exactly Kubernetes works? First of all, there is etcd, which is a database. It's a NoSQL database, file storage kind of database. And it's interesting the fact that etcd, due to how it works, it uses the Raft protocol, and it needs to have consensus to ensure that you don't have split brains or any kind of weird issues. So that's why you need three of those, at least three, and usually it's an odd number for mathematical reasons. And that's also the reason why Kubernetes, and we'll see also OpenShift, will need an odd number of nodes. API server is the Kubernetes API, is what usually people think when they think about Kubernetes. Those are the APIs that store all the data into etcd and allow all those that data to be settable and queryable. There is then the control plane node, which is basically a node where etcd and API server actually run upon, and a worker node, which is where your application will run on. Now, there are some situations where a node can be at the same time both a worker node and a control plane node. That's fine. But obviously, you will have the resources that will be used by both workloads. We then have the infrastructure node, which is any node. This is not really an official definition of what an infrastructure node is, but usually Kubernetes admins think about the infrastructure nodes as nodes where their tooling works and runs, more than nodes where their users' workloads or the business workloads actually run on. So you might have infrastructure nodes or not. That's basically depending on what needs you have. But there are situations where it might make sense to split out all the infrastructure kind of workloads to specific nodes, and those would be called infrastructure nodes. And nowadays, hybrid cloud and multi-cloud is kind of the new norm. And if you look at some data, those I think are a couple of years old, but still very relevant, and still it does not really change much. And the fact is that the majority of people queried by IDC in this case think that they will use multi-cloud or hybrid cloud scenarios. And I think it's very important to think about this in a wider way, because in reality, if you think about hybrid cloud or multi-cloud, we are really talking about heterogeneous environments. That's really what we are talking about. So in a way, also having x86 machines and S390 machines, that's kind of a non-homogeneous environment as well. And I think that this is very important, and the value that Kubernetes can bring us is exactly that abstraction of the underneath infrastructure, which could be uh, different architectures, different installation, different providers, and so on. Now, obviously, it's not a full abstraction. It's going to be a leaky abstraction. And in many cases, we will be able to leverage this, as we'll be seeing later on. So this is kind of the picture of what usually it looks like. You do have a bunch of bare metal, which could be x86, S390, PPC, whatever, virtual machines, same thing as for the architectures, and private public clouds. Also, in those, you can have non-x86 machines, and then you would have OpenShift, for instance, or Kubernetes, and then your application running on top. That Kubernetes can be stretched or multiple Kubernetes, but still your application will have much more flexibility of running in one place or the other. Now, as for OpenShift itself, what it is basically an opinionated version of Kubernetes. Consider that the whole OpenShift is fully open source. So you can potentially do it yourself, but also without the Red Hat support and everything else. And if you look at this picture, there is that integrated DevOps services. From there below, it's what we call OpenShift. So effectively, there is the Linux part, because we are talking about Linux containers. So obviously, Linux will be part of the conversation. Then Kubernetes itself, and then a bunch of other services that allows you to be more efficient. So when we are talking about OpenShift, this is really what we are talking about. Then there are other things on the top, still fully open source, but that give you additional features or capabilities to your management or workloads. Now, if we are talking about OpenShift itself and into S390 mostly, but that's the same thing actually apply for all the other architectures. There are three major install options that you have to pick between. The first option is the SNO, or single node OpenShift, which means that basically you are installing everything on one node. Installing everything on one node means that you don't have that three etcds that we talked at the very beginning, but we only have one, which means that if that node goes down, the whole cluster goes down. Now, that's not really a problem because the whole cluster is still the same node. So if that node goes down, by definition, the whole cluster would still go down. So it can be a very good option if you're doing dev or test, not really a good option for production, obviously, but still, it's very small and easily to install, manage, and everything else. And if you are only doing dev test, and you're willing to have your machine going down, your systems going down. If that machine goes down, then it's fine. The second option, which is slightly bigger, is the three nodes cluster, which means that we do now have three nodes, which means that we can have the three TCDs, one per node, but we are going to co-locate the workloads with those control plane nodes. So effectively, it's that case that I mentioned before, where we have control plane and worker nodes that are effectively the same nodes. Now, the advantage of this approach compared to the single node OpenShift is that also we now have high availability because we can lose one of the three machines at any given moment in time. But obviously, we are sharing those resources between the control plane and the worker nodes. So if we have X amount of resources, there will be a limited amount for our workloads, while the others will be used by the control plane. And it's important to ensure and put all the correct limits on the workers on the workloads, so that basically they don't saturate the cluster, because if they saturate the cluster, obviously the risk is that they bring down etcd and all the other critical components. Now, if you're thinking about production, then you would have at least 5 nodes. So those would be 3 control plane and then at least 2 worker nodes. So in this case, we do have that split in between the control plane and the worker node, which guarantees us that whatever happens in the worker nodes will not affect the control plane and therefore the stability of the cluster itself. Now, all of this, those can be VM, can be LPARs. Still, the important part is that there is that segregation and those options 1, 3, 5, basically, and plus to choose in between. Now, it's possible to install a full S390 OpenShift and everything works. Lately, we have a couple of interesting features, I think. So in version 4.14, which is not the latest one, it's the one before that, so effectively it got released 4 or 5 months ago, we got the ability to have a cluster on x86 that then gets additional compute nodes on S390, which means that you would have that full control plane on x86, maybe a few nodes on x86 if you need them, and then you can have additional nodes on S390, which are only worker nodes or compute nodes. With the latest version, we actually got a more interesting, I think, layout also available. The old layout is still available, but the new layout is that you can create the cluster on S390, so the control plane on S390, and then have additional x86 nodes added to it. Now, at the moment, those are the only 2 options. So you either have the control plane on x86 and the nodes on x86 or S390, and or S390, or you have the control plane on S390 and then the worker nodes on x86 and or S390. In the future, probably will also get more flexibility, so you will also have the ability of adding to an S390 cluster, maybe some ARM nodes or PowerPC nodes, and I think that will give us even more flexibility. And I think you are starting to see that there is a lot of options and things that you might want to do with this. And I want to propose you a point of view, basically, or something to think about, which is Linux One as a management hub. So you can have the Linux One as a way, as a tool to manage other systems, in addition to obviously do all the usual things that you do on S390. And one of the tools that would allow you to do this is Red Hat Advanced Cluster Management, which is an open source software that we distribute, which is basically a tool that is running on top of one OpenShift and is able to manage other OpenShifts. So what you can get out of this is a single pane of glass to manage a bunch of clusters that could be either on S390, x86, Power, potentially, whatever you have them. And you can have those on-prem. Because if you go on some clouds, there are similar solutions that they offer, but they are provided by that cloud and managed by that cloud. So effectively non-on-prem. While in this approach, you would have them on-prem. Due to the flexibility of the system, you can have any kind of Kubernetes container environment that gets managed by Red Hat Advanced Cluster Management. And consider that in this case, you can have maybe some OpenShift, maybe some other kind of Kubernetes if you wish to, and still be managed on the same platform, on the same pane of glass. And also, some of those can be S390, other x86, and so on, as we mentioned. And this also actually includes the Kubernetes that you might have installed or might want to install on public clouds. So those are both the ones that are installed by you on the public cloud, so maybe OpenShift on the public cloud, but also managed services, Kubernetes based, by the public cloud. So in this way, you can have a centralized, integrated pane of glass where you can see and manage every single cluster in your estate. And also another aspect is that you can automate a lot of things and ensure that they are running in a consistent way all throughout. An example, for instance, is using OpenShift pipelines. So with pipelines, which are CI/CD pipelines, effectively, you can have a cluster maybe on your management hub that automatically deploys some changes, for instance, to all the other clusters. So you might be on that pane of glass and decide that a certain version of the application needs to be upgraded everywhere in your estate. And then you can kick a pipeline that would exactly do that. Also, this would have effect everywhere where you choose it to happen. Now, a while ago, I was at the GSE conference, that was an in-person one, and during a conversation, someone was like, well, aren't containers actually making harder to justify the use of S390 for certain workloads? And I don't really agree with this. I think that the reality is that containers will only enhance the platform, will not displace it. And there are a lot of reasons for this. So let's start on why containers or OpenShift altogether make sense on a mainframe. It can provide you application development consistency in between that mainframe and other mainframes, or that mainframe and other non-mainframes environments. You can also leverage a lot of knowledge and tools that got created for containers, not specifically for S390. And also it will allow you to have portable workloads from one platform to the other. There are some caveats to this. Also, if your application is platform specific, that would be harder, but still, containers make it easier, not always easy. But there are reasons why it does make sense to have mainframes under OpenShift. The first one is data gravity. If you already have that data on the mainframe, it's way easier, and obviously if your data is big enough or fast enough to be updated, it does make sense to process it there instead of trying to move it somewhere else and then process it there. OpenShift can be installed on helpers, and it will give you all the advantages of very low latencies in between helpers connectivity. Also, there is a consolidation point because, as we know, mainframes are way more powerful for unit of power and or cost than x86. They also guarantee way more business continuity or uptime. And also, mainframes have unique hardware capabilities. One of the examples are the crypto cards. If you have crypto cards in your machine, in your mainframe, you can leverage them from the containers. So effectively, you can still use all those nice features that you have on that platform. Now, as we mentioned at the beginning, containers are a leaky abstraction. So that's why we can see those hardware. It's obviously suggested to also have an alternative path so that basically if the container does not find that express card, it will still perform the same operation, maybe surely in a slower way, but still it will not fail. So that's obviously convenient, but it's very important to have that leaky abstraction because it allows us to freely leverage the resources, physical resources and capabilities that we have on the hardware that we are running on. So speaking about HA and DR on OpenShift and mainframes, There are a few things to remember. The first one is that OpenShift only handles pod failures, not node failures. OpenShift always assumes, and Kubernetes in general, that they have enough resources to schedule new pods. So if you have a 5 node cluster, one dies, all the pods that were scheduled there will get rescheduled on all the other nodes. Now, if your nodes are not big enough, then you will have a big problem. But that's not something that OpenShift can manage. In the other hand, obviously, a mainframe can manage very high availability nodes or nodes from an OpenShift standpoint. So effectively, we have a lot of advantages, mutual advantages here. A big point about OpenShift and Kubernetes in general, as we mentioned, is that we have a DCD, and it does need 2 out of 3 at least up, so a majority, basically, of nodes up. If you lose the majority, OpenShift and Kubernetes will not be able to schedule any more containers, which means that if you lose one etcd, everything works fine. If you lose 2, then all the containers that are already running will continue to run, but no new containers will be schedulable. So this means that if you are in a situation where you are losing a couple of etcd, probably you also are losing some other machines, because losing 2 out of 3 machines is not that common. So in those situations, OpenShift or Kubernetes can be very unuseful, because they will not be able to properly schedule new jobs, and therefore your application will probably start falling down. In the other hand, obviously, mainframes have very low RQ RPO, which allows us to actually ensure that etcds are always up and running, and also that we have enough resources available to schedule all the required containers. There is also a big point about RPO RTO, which is that OpenShift works at an orchestration layer. So it will tell the storage, for instance, to do certain things. So attach a volume, detach a volume, those kind of things. But if you have a multi-site situation, you will probably want a storage that is able to manage RPO0, RTO0 by itself. And then the only thing that Kubernetes will do is going to instruct him on where to attach the various modules, the various devices. While that all the high availability is relegated to lower levels, so in the stack, not importance. So it's key, the fact that you need to have that RPO0, RTO0, or lower enough for your workloads already set it before you start to put Kubernetes on top of it. So also there is an aspect which is that it's way easier for Kubernetes to think, for instance, add replication in storage, as all nodes, all data need to be replicated in a certain way. So that's something that Kubernetes can do. In the other hand, we know that in the real world, there are some workloads that are way more important than others. So with mainframe technologies and methodologies, you can actually have that kind of preferences. So in the end, putting them together, Kubernetes and OpenShift in one hand and the mainframe in the other, will give you much more value than just one of the two. So wrapping up, it is key to focus on portable application. Portable application will give you a lot of flexibility. Containers can bring new tools to mainframes. Some of those tools can be very positive and they will stick. Others maybe are not as good as the one that you already have, and you can skip them. Mainframes are a great platform for containerized workloads because they have all those hardware capabilities and resiliency that can be very useful to the workload itself. And also OpenShift allows you to have that flexibility of platform and so on, but still having the advantage of being able to use specific hardware capabilities when needed. So with this, please leave feedbacks. If you have any questions, please raise your hand and we can have conversations.
I can't see any questions at the moment, Phil. No, I think everybody must be desperate for a coffee then. Very good session there. Thanks very much. I enjoyed that very much.
Thank you.
If you do think of any questions, then please do catch up via email after the event, and please provide feedback using the links available. This is session 3E. Thanks very much, everyone. The next sessions will be at 4 o'clock, and on the DevOps stream, it's bridging the gap, COBOL to Java. Take it to the next level with Python, Go and Node.js with Chandni Dhanani. So see you in about half an hour. Thanks, everyone.
Thank you. Cheers.
Thanks, Val. Really good presentation. Well done.